Welcome to this month in IPFS. Good morning, afternoon, evening, depending on where you're joining us. Really thrilled to welcome you to the first episode of this live stream. A bit of background, because this is the first live stream, and I hope that you bear with us in case we have technical problems, although we hope that the internet and the demo gods will be with us today. This is a community-oriented live stream, and our goal here is to create a space to share and learn about all of the immense progress that is happening in the IPFS ecosystem. If you are new to the ecosystem, or if you've been in the ecosystem for a while, you may have noticed how much has been happening in the last year, and now we're starting this really exciting new year of 2023. And there's just so much happening. There's so many different working groups. There's so many different apps that are being built now with IPFS, and there's the broader sort of DWeb movement, decentralized IDs. There's just so much to cover, and so the idea is for us to create this space and for you to come and join. And if you have questions, please drop them in the chat. Also, just for the fun of it, drop us a line where you are joining us from. I'm joining from Berlin, Germany, where it's cold. I've got a cup of tea here, just staying warm. And we have 3 guests today. Our first guest is Discordian. Discordian has been actually with the IPFS community for a while, and he is also a developer advocate like myself for IPFS. With that, Discordian is going to join us in a moment on the stage, and he's going to tell us about what he's been building. So let me bring Discordian onto the stage. Discordian, it's great to have you. How's it going?
Hey, going pretty well. How are you?
Pretty well, pretty well. Trying to keep warm here. But yeah, no, there's been a lot of fun stuff happening in IPFS world. And that includes the project that you've been working on.
Yeah. So I've been working on a project called Disco Chat. It's got some interesting features. It's a peer-to-peer chat application that it supports sending videos, images. It has full markdown support, emojis, end-to-end encrypted messages, mutable profiles using IPFS CIDs and IPNS, and honestly, just a whole bunch of other cool features.
Great. How do you feel about giving us a demo of this app?
Yeah, I would love to. I have one ready right here.
Okay, so let's bring your screen onto the stage. And here we have it. So we're looking now at the Disco Chat UI, is that right?
Yes, you are. So yeah, this is the Disco Chat UI. It's currently in development. It's at version 0.2.1. Actually not sure if that version's out yet. But yeah, we're connected here. The user list currently disappears once in a while, but it's otherwise working. We are connected. We can send messages, which are the important things.
Yeah. So I'm running this too, I should admit.
Yeah, and we can send images. Those should work. So if I send it on my end, you should see it. Just takes a second. So what's happening is it's adding the data into a Kubo node in the background, getting the CID, serializing it into JSON, sending it over, and then your client's deserializing it and sharing it. That's assuming the demo gods will be kind and allow this image to send, but it doesn't usually take this long.
And one of the nice features in Disco Chat is the fact that it's encrypted. So you've actually implemented end-to-end encryption there, and you're doing like a Diffie-Hellman key exchange. You're doing like a lot of really cool stuff behind the scenes. Is the end-to-end encryption, is that just for direct chats? Because now we're in a group chat, right?
Yeah, so the way it works is end-to-end encryption sort of so you have this drop down here. So I can select Daniel 2 color. We're still in the global room, but if I send a message to you like, hey Daniel, it encrypts the message and sends it into the same room, but it's set up in a way that other users can see who the message is for, and they know not to attempt to decrypt it because they can't. But effectively, you're sending secret messages in a public room.
Gotcha. So it's using the same pub sub channel. So this is relying on gossip sub, right? In order to do the sort of propagation Would be really interesting to see how this plays when there's more people joining. Um, Very cool. I'm really curious to hear a little bit more. So, how did you use IPFS, and what are some of like the building blocks of this app? Because this is a native app, is that right?
Yeah, yeah. So this is a desktop application that uses a web view to display it. So this is like a web page. It's the development version, so I can actually
Oh
open
wow.
up the
Okay, we've got the full
yeah.
inspector there, the developer tools.
So yeah, a lot of people will be familiar with those. So basically, JavaScript. If you're familiar with that, this will be hopefully, relatively easy to use and understand. But what's happening here is we have a library called the Kubo RPC client, I believe, and that is a JavaScript library used to connect to a local Kubo node. So what Disco Chat's doing is it bundles up the local Kubo node, starts it up for you in the background, and uses this RPC client to communicate it with it. Um, this is also done a little bit with the help of Rust. Tori is built using Rust, and I put some work into exposing some of the harder to find things, like it sets a random port to listen on, and then the port's exposed through a JavaScript callback. So that way you can communicate with the Kubo node, and if the user already has a Kubo node installed, it won't conflict with it. Um, yeah, that's basically how it works. Like, it originally used JS IPFS, and it had a node running in the browser, but um, right now it's running on desktop, demonstrating, like, honestly, I think the maximum of what we can do with IPFS right now. Kubo is pretty full featured.
Yeah, and I just dropped a link to the source code of
Oh,
this,
thank you.
and I'm curious because I know you've been working on this for a while. What was some of the challenges that you hit along the way building this app?
Yeah, yeah. So I mentioned before that it was in browser. Most of the challenges began there. It's difficult to do peer-to-peer things in a browser, um, because you can't open your own sockets. You're mostly dealing with like WebSockets or WebRTC. Um, and so if you're using WebRTC, you have to have like a star node, which advertises the path to connect to you. And then you have to connect to that star node. So some people don't like that because that's automatically like a little bit of centralization right there. But that's what gives you direct browser to browser communication. Um, that's a little finicky to work with. And then you had relays via Circuit Relay V1, and these operated like turn nodes, so it would forward all of the data. So this relay node would really be trusting you, because you can really do whatever you want with it. You can pass as much data through it as you want, and it wasn't authenticated at all. So that wasn't a good long-term solution either. So then had to move everything onto the desktop, and I had to figure out how to do that. Electron's a popular solution right now to have like a web thing on a desktop, but there's a lot of negativity surrounding Electron, from different camps. So either it's too big and too bloated, it's too buggy, which you can argue that there's a
Right.
lot of configuration too. So it's usually a configuration issue. Um, yeah. So there were, and then I guess the final issue that I'd like to bring up is more IPFS specific, because it's to do with pub sub channels, and this issue is not actually completely solved right now, due to a limit. I think in web views, I can only have 6 sockets open at once. So this actually limits the amount of rooms we can join. And a lot of these little hiccup issues that we're having right now are because it runs into socket limits and then waits for one to expire and opens a new one.
And it's probably worth flagging. So this is actually an issue. So when you're opening up when you join a pub sub channel, you're essentially trying to find around, I think like the pub sub, the gossip sub protocol tries to manage about, I think 5 to 6 connections open for that specific topic. So each topic basically multiplies the number of these 6 connections that you have open. Obviously, if there's 6 other peers connected to that
Yeah.
same topic. Is that a good way to understand it? And is that constraint a web view specific constraint
Well,
of Tori?
actually, so it is so JS IPFS initially implemented a configurable limit for the 6 socket limit, which is a usual thing in most web browsers. That's where that limit comes from. I'm not entirely sure why they agreed on 6 or how, but So it's not a Tory limit. Actually, you have a good point where Kubo can actually handle a lot more connections than just 6 at once. And we're not actually constrained on that end. So when we subscribe to a topic, you're right that a bunch of connections open, but specifically the socket connection that we're worried about and what hits our limit is because we're using that RPC client to talk with the Kubo node, we have to actually have a socket open at all times when we subscribe.
Right.
And yeah, it just passes data as it pleases through that connection. So if we want to be connected to 6 rooms, we have to have 6 topics. Currently, the way Disco Chat works too is there's also a backlog channel, which is a separate subscription. So when you join a channel, you're actually joining at least 2. And then any other operation it does, like be it like an IPNS lookup or something like that, is another socket that's open for a little bit. So effectively, the more channels you join, the buggier Disco Chat gets right now.
Got it. So again, it's important to stress this is a peer-to-peer application. There aren't any central servers involved. You can run this today. I've also dropped a link. I want to ask you, so what is next for Disco Chat? What are some of the next things you want to work on for it?
Yeah, that's a great question. So I've been working on Disco Chat for a long time, and it's generally in the back of my mind. Um, in its current iteration, I would like to see it more cleaned up, maybe tackle some of the bugs to make the user experience a little bit better. Because in terms of features, I'm pretty happy with it. A feature that is notably missing is file sharing. It's a bit strange that you can share pretty much anything except files. And then the killer thing that I want though is, well, I guess 2 things. I would like to see the browser version, if at all possible, of Disco Chat to return again one day. And then I want to see a mobile client. And I don't imagine a mobile client looking like this. This was kind of made with a desktop UI in mind, but I think it would be really cool if there was, like as you mentioned, a completely serverless, totally distributed chat application that even if you're not 100% guaranteed to get a message when it's sent, that eventually you will, and hopefully that's good enough if people want something totally serverless.
Got it. So, quick reminder: if you have any questions, please drop them in the chat. Also, you can probably, if you have any more questions and you want to ask them async, you can probably drop them in the repo. Anything else you want to share, Ryan?
Yeah, I just thought of something, and I think it's because Jay Chris is here, but there is another feature that I was excited about. So currently, because everything is serverless, and unless somebody trusts you, in which you'll automatically store some of their profile information, stuff like that. But basically, more or less, when you turn off your node, your data is gone. I want to add a Web3.storage feature where you can move your IPNS keys onto Web3.storage if you want, but also store some of your data backed up on Web3.storage, maybe with like a convenient little button that pops up. Yeah, those will be a couple more simple features that I think will be coming sooner.
Cool, very cool. And I think it's also worth pointing out, we're going to get to this later in this show, some of the new features in the latest Kubo release, one of them being a new protocol. And this sort of touches a bit of the work that you were doing prior to this, trying to get a chat app without any sort of central servers in the browser and some of the challenges that you hit there. So anyways, we'll get to that. Anything else you want to share, Discordian, before we wrap up?
Nope, just that I hope people give Disco Chat a shot, play around with it, and maybe break it if you're feeling it.
All right, cool. And again, I'll drop the link. You can find that on GitHub, and you can see probably the link just below me. All right. Once again, thank you, Discordian, and we hope to have you here again soon.
Thank you for having me.
All right. Okay, next up, we have David Justice. David Justice is an engineer on the browsers and platforms team. And he's going to show us a new browser extension that he's been working on. So with that, I bring you. Hey, David, how's it going?
Hey, pretty good. Thanks
Thanks
having
for
me, Dan.
joining us today.
Mm-hmm.
So you're working on the browsers and platforms team, along with Dietrich and a few others. Can you tell me a little bit about the work that you're doing as a team? Because what you're going to show us today is one part, but there's a lot of like other pieces that are part of your team's work, right?
Yeah, absolutely. I guess probably a good place to start would just be to like what our mission is. So our mission as a team is to increase the adoption of IPFS and Filecoin in long-term areas such as like browsers, mobile, space, and possibly metaverse. We try and achieve this by like collaborating with teams in and outside of the Protocol Labs network, people that have like shared goals with us as wanting a decentralization of the web. Some of these like integrations that we're trying to get into are open to full IPFS nodes like Brave browser, while some of them are see it as like a harder sell or a larger like technological feat to just to integrate it. In some of those cases, we try and get some of the core principles of IPFS into them as like a way to get, open up these doors. Some of that's like content addressing, cryptographically verified data. Sometimes we can start with some of these smaller like building blocks and edge our way in to getting decentralized technology in. Some of this can look like bringing these tools to the web platform itself and in web specs so developers can deploy to their users using mainstream web browsers. And then we'll be creating interoperable specifications to make those easier to implement across all platforms and applications as much as we can.
Gotcha. And sort of how does that sort of specifically relate to what you've been working on and what you're going to show us today, which is this browser extension essentially, right?
Yeah. So I've been working on a couple different things. I made like a little list so I can kind of drop a couple different projects, and then I'll kind of end with like the pin tweet stuff, just to give like an overview of some of the other projects we're working on too. So one of the main ones I work on is called Durin. It's an application that makes viewing and uploading content on the IPFS network a lot easier on mobile devices. We're also using it as like a testing ground where we'll be able to try out ideas around file sharing, verifiable content over peer-to-peer transports, exploring connectivity over users' social graphs, which is probably going to be like Contacts API. We've been working with a company called Trigram with that one too, and they've been really helpful. Another thing that we're probably going to be starting up soon is I'm working on a new blogging framework. So we're basically building a team blog for the browsers platforms team. What's interesting about it, though, is it uses all IPFS technology and protocol labs types things. And then we're also hopefully going to be running a smart contract on FVM to connect all these pieces together. So it's going to be a decentralized blog. I think what's interesting about it is that we're trying to establish these patterns that I believe all sorts of applications will be able to be built on. So we're going to start with the blog, but I think that we might be able to see like an explosion of different ideas afterwards. Really excited about that. Obviously, we'll do some more like announcements and things around that in a couple months once we get like some MVPs going there. And then finally, Pin Tweets IPFS, what this is about. It's a browser extension, and the goal is to help users pin web archives of Twitter content to IPFS so they can maintain a copy if it gets censored by the platform, deleted by its author, or anything like that. While it fills a specific need for end users, we feel that it could provide value to publishing platforms as well. We have a new team member, Robin Bergeon, who just joined our team in Q4 in 2022. Used to work at the New York Times, right? So we were talking through this issue, and he was saying like it's a big concern there that a lot of these publishing platforms we link to and embed content from Twitter and other platforms, and when it's deleted, your article just has like a huge hole in it, right? And like these are references, like they need to be held onto. So obviously they could just use screenshots, but then there's like a lot of issues of people being like, well, was this screenshot modified? Things like that. So people want to be able to verify that themselves. So we think that maybe we could expand these types of use cases to have this verifiable embedded web archives and get them more into like end users' hands and also publishing platforms' hands, so people can have this longevity and just more credibility across these platforms. We're still in very early conversations with that one, but I think that's one of the really exciting things that could come out of this.
Yeah, and a big shout out to Robin. He just published a really interesting blog post on his blog. I'm going to drop a link to that in the chat. Okay, so we have this pin tweet to IPFS, and you've prepared a demo for us. Can we get that rolling?
Sure, yeah.
Let's do it.
This is a demo of a tool from the Browser Standards and Platforms team called Pin Tweet to IPFS. PinTweet is a browser extension which helps users pin web archives of Twitter content to IPFS, so they can maintain a copy if it gets censored by the platform or deleted by its author. Starting out here, we're on the GitHub page. Scroll down and we'll see it's available in the Chrome Web Store and also for Microsoft Edge. Firefox support coming soon. So we'll go ahead and click over to the Chrome Web Store, add it to Chrome, get that added. Let's go ahead and pin this to our browser window so it's a little bit easier to access. And we'll go ahead and navigate over to Twitter. I'm going to refresh this page. As you can see, we embed a button here so that we get really quick access for a user to go ahead and click this and pin it directly to IPFS. Since we're on a Twitter permalink page, we can actually just click our badge that's added to the browser for us, and we'll go ahead and get redirected. This is a tool from the WebRecorder team that they made special for this project called Save Tweet Now. It utilizes their Express tool where they archive web pages in the browser specifically for tweets here. So what's actually happening here is they're going to pull that tweet down, put it in its embedded form, and then turn it into a web archive zip file, and then upload that to web3.storage link. So now that we have our link, we have a little info about the archive. We can go ahead and click that, and it'll navigate us to our embedded copy of the archive. So here our web archive is loaded. You see we have the whole tweet here. It's interactable. It will link outside. We also have some information about the archive. We have the original URL, which is the OEmbed link. We have the public key, some other validation information, and another link to download the whole archive there. After this has been uploaded to web3.storage link, we can actually see that we have a panel that pops down here as long as you're not on a permalink page, where we have some info about the tweet and links to it, and we can copy the link straight out of there. All of this data is shared locally, so you don't need an internet connection for it, and you still have access to your archive tweets. So it's local first. That's the demo. Listen for the rest of the talk to get more information about it. There's a GitHub. This is where you can find me on Filecoin Slack. And again, that's the GitHub name. Thank you.
Oh, that was great, David. I think that was a pretty good run of the code. Is there anything else you want to share? By the way, I just dropped a link in the chat. If you're watching now, you want to check it out. There's a link to the open source repo, and there's also links to the different app stores for Chrome and for Microsoft Edge, I believe it is, right? And you're also working on the Firefox version of this.
Right. Yeah, there's been, I'm sure like anybody that's familiar with web extension stuff is familiar with Manifest v3 and how there's been like a lot of confusing things going back and forth between the browsers with that. So can't fault Firefox for this being difficult to implement there right now, but because it's definitely not their fault. But we are getting really close to being able to add it to Firefox. So as a former engineer at Firefox, it breaks my heart that we don't have it there yet, but it will be soon. So it's okay. As far as adding something else, I did want to just mention a little bit about the WebRecorder team. So they're like a wonderful team that works with web archiving. They collaborated with us heavy on this one and on other projects also. Just to tell a little bit about them, they build these like web archiving tools that are user driven, that are mostly in browser and like all around like the user being able to actually archive their own content on their own terms. And they really share like our mission with that, which is just like user agency should be one of the top focuses, right? So they made this special version of Save Tweet Now for us, and it's just been like super helpful and basically made my job on this, writing the rest of the extension, a whole lot easier. So they're definitely like a really incredible team to take a look at. I don't have a link accessible right off the bat. I think it's webrecorder.io, but I'll drop it in the chat like right after.
Yeah, I dropped it just now. I believe it's webrecorder.net.
That's the one. Thank you.
And I wanted to ask you, so as far as my understanding goes of WebRecorder is a general purpose tool that anyone can use. It's open source too, and it can be used just to archive pages on the web and sort of to get a downloadable version of them that is viewable without internet connection, and that can be sort of persisted on any sort of external hard drive, NAS, or even in the cloud. Is that a good model for that?
Yeah, that's a really good description of it. I think that even after I was told that initially, I was still blown away when I actually started playing with it. I went to like YouTube pages and things that I just so associate with being online to be able to view them. And I recorded some of these pages with lots of different interactions and notifications and things coming up. And then I, turned my Wi-Fi off, unplug Ethernet, and tried to play it back. And I was just like, every single part of the page works. This is insane. And I would open up the network tab and everything's replaying. Like, I'm really blown away by just how like all encapsulating it is. And it totally works like that. Another interesting thing about them, while it is totally available for end users, they've been working more and more with libraries and archiving and other archivists, which is just like a super important thing for our world right now. So I really appreciate that and want to give them props for like working with all these archivists. So
yeah, so shout out to the WebRecorder team. Tell me, David, what's next on your plate?
Sure. I mean, excited to start this blogging stuff. We have some things coming up with PinTweet, mostly just like some little UI things. We just want to make it as smooth as possible, easier. I do want to add a little bit more support for using different pinning services, bringing your own Web3.storage account to the pinning service, because people want to organize their stuff in every way that they want to, and they should have the total right for that, right? Like we're talking about user agency. I also would love to explore a little bit more for like connecting to local nodes. There's a lot there. There's a whole lot that we can get going here, and maybe eventually connectivity with Durin. We'll see. I mean, we're just going to kind of keep pushing all these things at once and seeing where we can connect and meet, So
yeah, so right now it's basically using one account, right, of Web3 storage, and you mentioned of bringing your own account and using multiple pinning services. The idea there is that you can actually sort of pin it to your own account rather than a shared account that is sort of controlled by the plugin, right, or by you essentially.
Exactly. Yeah.
Even though you get this interoperability with IPFS that even right now, once it's sort of uploaded, you can go and use, the pinning API spec, or you can just go to your pinning service and you can, or run on your node, you can go and you can actually pin that SID and you'll be able to replicate it from the network.
Exactly, yeah. But some people maybe want to just have it already attached to their account. So I want to give them that option, obviously, So.
Yeah, absolutely. And I think also this kind of like speaks to one of the big benefits of content addressing in IPFS, which is kind of you get this interoperability and you sort of like you get this ability to control your data and own your data. Mm-hmm. So great. If you have any questions, please drop them in the chat. We can see all of your chat messages coming in. We had a message actually from JPL who also shared some kudos to Robin about his Cambrian governance internet transition blog post that I also shared. Anything else you want to share, David?
I think that wraps it up for me. Yeah. Thank you, Daniel. I appreciate you letting me show this stuff off today.
Glad you came. Where can people find you online?
Probably I'm not like super online these days, like as far as my accessibility, but my GitHub, Mean Dave Justice. I'm on the Filecoin Slack, Dave Justice, usually in the browsers and platforms channel, browsers and standards. Email is work@justice.engineering. So those are probably like the 3 easiest ways to get in touch with me.
Gotcha. All right. Thanks, Dave.
Yeah, thank you.
All right, next up, we have our final guest for today, and that is Jay Chris. Jay Chris is an engineer on the Web3 storage team. So he's going to talk to us a bit about some cool stuff that he's been working on. So with that, I'm going to bring Jay Chris to the... Hey, Jay Chris, welcome.
Hey, Daniel. Glad to be here.
Glad to have you. I'm glad that you also have behind you a Monstera plant.
Yep, it is the season.
Yeah. Well, I mean, you're probably in a slightly warmer place than I am. But we're not going to talk about the weather or plants, right? We're going to talk about some of the cool stuff that you've been working on with Web3 storage.
Yeah, we've got some new things to share, and also just I kind of wanted to give props to the tweet pinning archiver that David was sharing, and also say that if anybody goes and forks that and makes it save Chat GPT sessions, I'll totally give you a Web3 storage T-shirt.
Okay. So where can
Um,
people find you online if they want to do that?
Well, if you go to the web3.storage site, we've got links to our Discord and our Slack rooms, and they're all bridged and stuff at the bottom of the page. So that's a great way to find me. Or I'm jchris on GitHub and Twitter and other services, so you can find me online that way.
Great. And tell me a little bit about what sort of you and the rest of the Web3 storage team have been working on, because it's like it seems like your work spans quite a wide array of different aspects of IPFS, but also like bringing it to the mainstream UI work, a lot of developer tooling.
That's right. So our big goal is to be the easiest way to get data onto Filecoin via IPFS, and the easiest way for developers to write IPFS apps and get to know IPLD and all the cool features like we saw in Disco Chat. So to that end, we built a bunch of these developer tools, and we got a bunch of adoption with them. And then we realized kind of the next step, which was how do we run this in the most cost-effective way? And it turns out that these distributed protocols are super good at that. Hash content-based addressing is real easy to cache. And then beyond that, and this is what I'll show here in a minute, the UCAN distributed auth protocol that we use allows us to avoid a whole bunch of extra copies of the data, and in the future, designed to allow different services to interact on data by pushing compute to data and avoiding all those extra copies and keeping costs low. So now we're looking at how we can take those protocols and use them like more widely in the IPFS ecosystem to make things more efficient and faster.
And I believe I heard UCANs at some point.
Yeah, so UCAN.xyz, and I'll show this site here in a second, is a distributed authorization protocol. You can think about it as solving the problems with bearer tokens. So the problems with bearer tokens all come from the fact that while they're cryptographically signed by the server, so the server knows they're not tampered with, they can easily be copied or stolen, and replay attacks and all those problems come from that. So what UCANs are is taking that idea of cryptographic signing, but extending it also to the client, which depends on the client having a robust cryptographic key situation, which all of a sudden, in the last few years, that got easy. So UCANs are kind of the right thing for the times to distribute capabilities and invocations across a distributed network, where like a bearer token getting stolen is a problem. UCAN is designed to be safe to store and forward, so it allows services to collaborate by sharing invocations across different infrastructures.
And when you speak about bearer tokens, are you referring to like the open auth bearer tokens that you usually get from like basically using a third-party authentication like Google or Twitter or GitHub, kind of like that classical Web 2.0 authentication flow where you don't actually create a new account, you're relying on an existing account that you have with one of these sort of big cloud or big platforms?
It's broader than that. So it kind of doesn't matter these days how you authenticate into one of these microservices applications. Then when your API call goes out and starts, going through the tree of microservices that it takes to compose the result, it's going to send, different kind of, verification validation tokens through with it. And these days, because those are meant to be used for the length of the session instead of for a single invocation, right? It opens up all those holes. Whereas with the UCAN, the client creates and signs each invocation individually, and so they can't be replayed because they correspond to a particular cryptographic action.
And I'm curious, so how does this relate to decentralized ID? Because you mentioned that all of this relies on basically the client, like the user, having some cryptographic sort of identity which he controls, right? Rather than some kind of like externally owned one. So how does this relate to decentralized IDs and DIDs, which is an actual spec that specifies these decentralized identifiers?
So DIDs map to a whole bunch of the objects in our domain model. They map to agents and spaces. And so both of those correspond to a public-private key pair. And the important thing about using DIDs to address that stuff is that it allows us to rotate the key pair over time for security. So the actual cryptographic identity that's required to get into this world is very slim, right? You just need to have some kind of safe key custody, which it turns out that IndexedDB, local storage has a non-extractable key pair data type. So we can actually just manage a bunch of keys in the local IndexedDB in the browser. And what this means is that, like, if you're in a traditional Web 2 style app and you already have authenticated users and you just want to use Web3.storage, either via the client, which I'll show in a minute, or via the, components, the UI libraries, you can link that, our library in the client, which has that private key, to your existing session and start doing uploads right away. And the user doesn't see anything. It's completely headless. They don't have to log in. They don't have to know Web3 storage is there. So it totally fits into your existing identity system on a Web 2 app if you want it to. But because it's based on these public-private key pairs, you can do it in a more decentralized, user-owned manner. And that's the default when you use our UI components. So I'll show you how to get into that here on the screen in a second. And both of those, work with these user-owned key pairs. But when you do it according to the default flow, which we assume is easier for somebody who's just getting started, they're creating a fresh app, then the space, the uploads are owned by the user. And the big end result, I think, of that is that you can have apps that go viral, get super popular, and the developer is not on the hook for a huge bill. It can be the cost is distributed across all the users. So we think that'll change what apps look like in the long term.
So if I understood you correctly, one of the big benefits that you can do with these UCANs is that and with Web3 storage that supports them now, is you can build an app where instead of you, the app developer, having this like AWS account or a Google Cloud account or whatnot, and then, you basically have your token and you have your backend and a classical kind of like 3-tier app or whatever, a serverless function that has a secret with the token, right? And then that token is used to then upload to your S3 account or whatnot. Then instead of this whole model, the user actually is bringing his own kind of like storage credentials. And those might be an account on Web3 storage, or they might be, it's all open standards. So, tomorrow anyone could go and start a competing service with Web3 storage that, as long as they support UCANs and they support these standard APIs, then they could become essentially a backend and they could run the infrastructure and so on. And so the user is actually the one who's bringing his storage backend, so to say.
Exactly. And there will be in the ecosystem of UCAN services other providers of the same capability. So right now we're a storage capability provider, but you could have compute capability for running a WASM or a JavaScript block. You could have like a video transcode capability, and as long as folks are using the same signatures for those UCAN invocations, then you'll be able to swap out service providers as an end user.
I got it. Yeah, that's fascinating. Let's dive into the demo. Should I bring your screen up?
Sure, let's do it.
Righto.
And I'll send into the chat, the bit that users might want to copy paste.
Okay.
So what you'll see here is the latest version of the Web3 storage command line interface, and then I'll switch screens over in a second to show you the UI tools.
Can you make the font a little bit bigger? Oh, we're looking at the UI. Sorry. Oh, are we looking at the terminal? Yeah.
And this is my terminal. So
Cool,
right
cool.
now it's just the install command, and I'm running help. And I just kind of want people to see that there's, you know,
Can you make the font a little bit bigger? Just so you can see. Yeah, that's great.
So you can manage spaces. You can, you know, manage your identity within the system.
What is
and
a
you can
space?
upload files. So a space corresponds to a DID, and by default, you know, you have the one that's attached to your account. So if I were to upload this directory of files, it'll go into my space. And then like 90% of the time, users don't need to know what any of this is. As a developer, you might want to, you know the difference between the space that corresponds to your app and all the, you know, spaces that the users are bringing to the app. But you don't even need to know that. So there is a ton of flexibility in here with delegations that would allow me, for instance, to create a, let's say you told me your private key, your public key. I could sign a document that says Daniel can upload to my space. And then you could import that delegation into the command line tool here. And then you would be able to run, you know, targeting your install, a command just like this, and get the documents uploaded to the Web3 storage. So now I'll go over to the browser.
So you've just uploaded a whole folder of flower thingies. It says 41 files, and you got a SID for that.
Yeah, I'll go ahead and upload the motorcycles that I have next to them. And,
amazing. Let's do it.
And so, yeah, those are uploading. And back to some of the verifiability that we heard about in the earlier conversations. The CID that you see here is generated locally based on the data in that directory. This is for the car file, which is a bag of blocks. It's a transport mechanism for IPFS blocks. And what's cool about the way we manage this is you get this CID before the upload starts. And that allows you to do things like in-queue an integrity check elsewhere in your system while the upload's still processing, etc. It allows you to put this into a Filecoin deal of your own while you're waiting for the upload to happen. And
I'd like to pause on the car files because I feel like the car files, like people find it somewhat mystical. So I have this mental model, maybe you can verify this. My understanding of a car file that it's like a tar file or like a zip file, but for content addressed data. So it's kind of like you package up all of these files and you already know the SID. And you can do this on the client side, irrespective of the network. So even if you're in Cuba, somewhere sitting with your laptop, you can actually create all of these content addressed car files. You can know the SIDs for them and you can share them using USB sticks or whatnot. So it's like a way to do content addressing independent of the whole network.
A car file is a bag of blocks where like what you're used to in an IPFS address is a block. So one cool way to think about what you could use it for is like, say you did a build on your front end app and now you have an HTML directory that's your app deploy. You could put that into a car file, and then you know that any IPFS node that you ship that car file to will have everything that it needs in order to render that application. So it's all the blocks you need for something all together. And that leads to car transactions, which are the way that you work with like raw IPLD graphs and applications. Like you saw in that chat app earlier, what you can do if say you're extending a B tree to add a new entry to you know, a chat log or a photo gallery or something, and then you're also, you know, at the same time maybe adding a comment to go along with that entry and updating a counter somewhere else on the page. So that may be a handful of IPLD new routes that are being written into these data structures. And what you could do is put all those blocks that correspond to updating all three of those data structures into one car file and then ship it to any IPFS you know, service they can make those car files available over the protocol like Web3 storage does, and you'll have your transactions available for the other application users.
I see.
If you're a database geek, you notice I skipped over the part where we decide which transaction wins, and so that's more of an IPNS W3 name question, which maybe we punt on for now and let the experts like Discordian do it. So
sounds good.
We got these uploads in there. If I copy this URL, it should be fetchable over here on the gateway. And while we're in the browser, I'll show the other side of this. I'll just get this load started up. But if I go to the UCAN website, you can see that it's going to be familiar. It has a JWT encoding. It also has an IPLD encoding. So you can use it in your existing tooling, but it has signatures and delegations that allow it to be more robust in the way I talked about.
Yeah, like you can do all the delegations things. It's essentially it's like a whole extra layer built on top of JWTs, right? Because like UCAN tokens are just JWTs that have a certain structure, and they rely heavily on these like DIDs and the public keys and these delegation chains.
Mm-hmm. Yeah, and then we've I think this page is due for a refresh. Some of the work that we've done has been to make it so that it's more the protocol itself is more friendly to having things like the proof chain embedded as a CID instead of inline.
Okay. Yeah, because that can get big, right?
Yeah, and the nice thing about even a big proof chain is that whether or not it's trusted and validated, it can be cached, recursively. So even as it gets bigger, it's not necessarily more expensive to deal with.
Got it.
So back over to the UI components, and the reason I started with UCAN and then brought these up is because they make it so that you can use this UCAN stuff without even knowing it. They're designed for, you just want to get the job done. You want to win the hackathon. So you're going to put an uploader into your app by, copy and pasting this code essentially. And those use UCAN by default and get you logged in. So you as a developer don't have to work on the code that sends the email to validate that user has a Web3 storage account or any of that. So to give an example of what gets built with that, and this is just an in-progress app we're working on, but this is an app that allows you to put any file on here and upload it, and that's going to be part of the Web3 storage site when we complete it. So while we're over in the browser, here is I think the motorcycles, and if I click inside there, we can
all right, yeah,
maybe get an image. Yeah, so generative AI. I think it looks like he's playing polo.
Okay, yeah, that's like cyberpunk bike polo.
Totally. So if you want to get started with this again, you could just go npm install it, and you should have an easy time of, even when you run through setting up, registering a new install of the CLI, it's going to take you through the same email registration flow that you get from the UI.
I see. So if you are now sort of starting an app that needs storage and you want to sort of explore this whole idea of like building it in a way where the users own their data, they might be interested both in the UI components and then the CLI. What is the CLI sort of useful? Is it mostly for like the development phase? Is it just kind of like the S3 CLI where you're just kind of like doing things quickly from your terminal as you're developing?
It's meant for that, and then I think it's going to be, naturally a little bit easier to work with doing like a 10K NFT drop or other kind of large uploads. Both of these are going to intelligently restart your upload if something happens in the middle and you've got to pick it up where it left off. But people just like working with big files on the command line.
Yeah, very nice. And what sort of what do we have in store in the future with Web3 storage? I know you're working on a lot of really exciting things.
Well, currently we're doing a refresh to simplify this even more. And then after we've got that done, we're gonna, wrap it in epoxy and make an easy widget that anyone can drop into their like WordPress blog or anything to add uploads. So on the ease of use side, there's that. And then on the cost side, we're digging into how to make our write pipeline into Filecoin even cheaper to operate, and then introduce the read pipeline into the Saturn content delivery network so that we can have even more of our bytes flowing through the Filecoin ecosystem.
Very cool. Anything else you want to share, J. Chris?
I hope that people go out and write a bunch of apps and upload a ton of data. I think that there's so much low-hanging fruit, especially in verifiable data, like doing things like a verified ChatGPT uploader. If you look on the Web3 storage blog, you can see that we did an uploader for Stable Diffusion that includes the random seed and all the prompt metadata to make it easy to regenerate and archive all that stuff. So I think in this world of volumes and volumes of essentially functionally created data that's going to be coming out of AI models, the verifiable, hash linked, cryptographically signed data structures are going to have even more utility.
Amazing. Cool. And with that, I'm really excited now to bring David back up, and we're going to go through some broader stuff happening in the ecosystem. Let's see. Can we bring Discordian back on? Yeah, let's see how long we can get you for. Okay, so I just want to share some stuff. Thank you all, by the way, for joining back. We have a new community calendar. Have you guys seen it? You can find it at ipfs.fyi/calendar. I'm going to drop a link to that. That's not the one. This is the calendar. I'm going to also load it and share my screen and work through some of the different things that are happening there. Let's see. So ipfs.fyi, and let's share the screen. So this is our new community calendar. As you can see, we have obviously this month in IPFS. That's also listed there. You can go there and subscribe to future sessions. We also have the implementers sync, which is happening later today. This is where a lot of the implementer community is discussing some of the different upgrades to the protocols. They're discussing the specs. If you go in, you can actually should be able to find some of the notes from the meetings if you want to catch up. Discordian, you're also hosting later on, I believe tonight, the Interplanetary Office Hours. Is that right?
That is right. Yeah. Everybody's welcome. Really what we do is we just hang out. Sometimes people have new projects they want to talk about. We listen to their projects, or they'll talk about what grants they're going for and they want some advice. Or it's really just an hour of hanging out with people interested in Web3, distributed computing in general. It's a lot of fun.
Cool. And I also want to point out, so we have the JS IPFS triage. There's the computer over data working group. Move the bytes working group is a particularly interesting one. So this is a relatively new working group that was started at IPFS Camp in Lisbon. And the idea there was to try to come up with a new transfer protocol that would perform better than BitSwap, the current sort of exchange protocol that is used by IPFS. And so they're doing some really interesting work on benchmarking protocols, and also there've been a bunch of presentations on future protocol proposals. So that is led by B5, Brendan. He's also a very dear member of the IPFS community, and he's also hosting these sessions. And he's also the co-founder of IRO, which I also wanted to plug. And IRO is an implementation of IPFS that is written in written in Rust. That is. Has one of you had a chance to try it?
My answer should be yes, but it is no. I haven't tried it yet.
Yeah, I mean, I know it's
I've tried
quite experimental.
Yeah, I've been playing around with. They have a Rust library to talk to a Kubo node. I'm playing with that, but I haven't actually tried IRO it.
Cool. I'll drop a link to that in the chat. Be sure to check it out. Anything else? Yeah, we have the ProbeLab office hours. ProbeLab is the org that is doing a lot of the research and the network measurements. So they're like really analyzing the IPFS DHT, and they're also publishing all of this data onto GitHub. Actually, maybe I can find the GitHub ProbeLab. I can't remember where it was. Anyways, I'll try to find the oh, there we go. So we have this crawler that I wanted to mention, the Nebula crawler that Dennis, researcher, wrote, and it's basically crawling the DHT and doing some analysis on the network, and they publish some of the results on the IPFS network. Really, really interesting stats there that you can look at. I'll also drop that in the chat. And there's a new release of Kubo. So I spoke about, where do we have Kubo? 0.18 just went out. I had a chance to take it for a spin yesterday. Specifically, I was, so there's a couple of major highlights here. There's the new interplanetary network indexer. So this is one of sort of the layers that is creating interoperability between IPFS and Filecoin. And the idea there is that you have this basically a delegated routing protocol. So one of the major things that IPFS does is it sort of like helps you find the location of your content. And you know, we talk a lot about content addressing in the IPFS world, but even if you're doing content addressing, when you're fetching something, you still have to fetch it from a location. And IPFS, you know, through the DHT, and now with this delegated routing, that sort of does the magic of mapping a SID to an actual IP address of someone who's publishing that content. And so the delegated routing connects with these network indexes, which are basically indexing all of the data that is being stored on the Filecoin network. And so now we're like starting to see a lot of this interoperability between Filecoin and IPFS, and this sort of like is a bit of a callback to what Jay Chris was mentioning with some of the work they're doing to kind of like streamline the deal making process when you upload to Web3 storage in Filecoin. Is that a good way to like think about it, Jay Chris?
We're looking into how to make, and this is because UCANs make commuting over data locality, you know, like kind of transparent. So we could build a slab of like 32 gigabytes to send to a Filecoin deal that may be stored in, you know, S3 and R2 and some other place where we know where it is on a URL even. But we could still go through and do all the proof heads and essentially hand that to somebody who, you know, builds the final, you know, Merkle wrap up without having to even go do all that. And that way we can have the clients do most of the computation heavy Filecoin inclusion work as part of their upload rather than, you know, saving it for the end.
I see. Rather than everything kind of like flowing through you. I see. Another really cool feature that has been worked on is support for DAG-JSON and DAG-CBOR. I think we'll save like the details of this one for another session because I think it's a big topic that is worth discussing. But it's like the sort of the title of it, or the high level theme there is using IPFS for more than just files and directories, starting to work with structured data. And, you know, like, you know, it gets into like all of these interesting data structures like Prolly trees and B trees, and like basically doing databases on top of IPFS and content address data. We'll probably have a demo at some point going into more detail, but the gist of it is that we've added support for DAG-JSON and DAG-CBOR in gateways. Now, the main feature that I wanted to mention is support for Webtransport. Webtransport is a new protocol that is supported by browsers. So it's an actual specification. It's already implemented by I'm trying to find, so it's sort of specified by the W3C, and I believe that Chrome already has initial support for this based on like a draft of the spec. And the cool part here is that it's built on top of Quick. If you haven't heard of Quick, Quick is essentially basically a reliable transport protocol that is supposed to is built on top of UDP, but is supposed to replace TCP. And in fact, it is also the protocol that HTTP3 uses. And there's many benefits to Webtransport, which you can read about in the IPFS blog, and also there's a link in the libp2p blog. I will drop a link to that. And so now that's supported by Kubo, and one of the main things that is really exciting about this is that it means that the network, the IPFS network, is no longer going to be as segmented or fragmented as it used to be, because right now, if you're working in a browser, right, and I can see Discordian's already happy about this. If you're in a browser and you want to connect to an IPFS node like a Kubo node, then essentially you're constrained by the protocols that the browser gives you. WebSockets, HTTP requests, but if you want to do like real time or like, some more involved thing, then you have WebSockets, WebRTC, and now you have Webtransport. And WebSockets are nice, but WebSockets require a certificate, especially now in a world where HTTPS is ubiquitous and you're kind of like running from the secure site policy enforces it, so you can't establish a connection to any node if it doesn't have a certificate. With Webtransport, we figured out a really cool way in which you can embed a self-signed certificate and then verify the hash. It's kind of like in the spec of Webtransport, but essentially it means that you could connect from a browser to any Kubo node without the Kubo node requiring a certificate. There's also some performance benefits there, like there's the less round trips to establish a connection. So anyways, I think that's a really exciting thing, and you're probably going to see a demo in one of the future episodes. Two final plugs. You may have heard of our announcement that we're working to get IPFS working in space. And the key idea here is, we've been talking a lot about content addressing and how it decouples essentially the address and the address and of data from its location. And so you can essentially retrieve content from a source that is closest to you. And guess what? This is a really nice idea if you're working in space, where, a round trip from, say, a satellite back to Earth might be long, or, if we're talking about really like going interplanetary, these distances, even at the speed of light, can be quite a long time. And so with IPFS, you have this idea of like, locality, and you have the blocks locally, and you might be able to sync from someone else or another satellite that is closer to you. And so there's a lot of interesting research work and actual implementation that is happening here. And this is done in cooperation with Lockheed Martin. And they're actually planning to bring this work on IPFS onto their self-funded LM400, which is like a software-defined satellite about the size of a fridge. And that's going to be running some implementation of IPFS, which is open source, and it's written mostly in Rust. So I'll drop a link to that. And I see that Discordian, Quick is so awesome, exceeded my expectations. Anything else you want to specifically share? Because Kubo has been using Quick for quite a while, right? But what's been your experience?
Oh no, I'm just still happy about Quick. Since the moment it came out, I thought TCP was great, but UDP was much faster, and I thought there must be something better. That Quick came out, and I'm still just reeling by how awesome it is. Yeah, I didn't have anything too specific. I was mostly just listening to everything you said. It's really easy to listen to you talk, especially when it's about things I'm really excited about. I'm really excited to see us get into space. I can't think of anything cooler than that, to be honest.
Yeah. We have a website, right? Are we interplanetary yet.com? Let me just Google that, because I probably made a Okay, I probably misspelled that. Anyways, we'll drop a link if someone finds it. Final thing I wanted to mention was IPFS Thing. So IPFS Thing is an event that is mostly focused on the implementer community of IPFS. And so that's going to be taking place in Brussels, and we've already opened up the pre-registration. The dates for this are 15th till the 19th of April. Are you all going to be there? I'm wondering.
I will definitely be there.
All right, so there's your chance. If you're working on an IPFS implementation, there's your chance to meet David in person. Anyways, you can find the link to that in the community calendar. And with that, I think it's about time for us to wrap up. So if you've joined us, thank you for joining today on this first episode. We'll be back next month. And anything else you want to share, Jay, Chris, David, and Discordian? Thank you, by the way, for joining once again.
Thanks for having us. This has been like really wonderful. Again, yeah, it really is easy to listen to you talk. You're really good at presenting here. This has been awesome. I hope to see many, many more of these live streams. I think this is a great format. Really nice that people can drop questions in and then we can just answer them right here. This is awesome. So
cool. And I wanted to say, if you have any suggestions, the audience that is, and if you have any questions, this is a good space to ask them. And also, if you want to make suggestions, you can drop them at devrel@ipfs.tech. So with that, once again, goodbye and enjoy the rest of your day.
Oh,
Cheers,
great.
y'all.
Please join our community too. Oh, we didn't drop any links to join our community, I don't think. But yes,
Yeah,
thank
you can
for...
find the forum.
Yeah. Discuss.ipfs.tech. And yeah,
All right.
Thank you, Peter, for joining us.
All right.